Okay, welcome back. So, as I was saying in my last video, so for nonmetals, uh, the nonmetals get more reactive as they go up a group instead of going down because nonmetals want electrons. So, as you go up the group, it's easier to gain those electrons. So the easier it is to gain those electrons, the more they're going to react. So why is it easier to gain those electrons? So they have a smaller radius, so that means that the electrons are going to be closer to the nucleus, and so they're going to feel a greater force, of a greater attraction. There's less shielding because you don't have as many you don't have as many energy levels, and this means that you're going to have a higher electronegativity. So we said that atoms with a higher electronegativity want the electrons more, so they're going to have a greater um, attraction for electrons. So it's going to be easier to gain an electron with that higher electronegativity, and so it's easier for the nucleus to take one of the electrons from another atom. So So if we were to rank these elements, so if we practice a little bit here, um, ranking from small to big, let's talk about radius, right? So if we're going to rank uh, the radius of these atoms from the smaller radius to the larger radius, Kf, potassium, fluorine, and aluminum, uh, how would we do that? Okay, so I want you to pause this video and take some time to rank each of these sets of atoms or elements according to radius. So, number one, order those from small to big in terms of radius. And then for number two, order those according to ionization energy, so from small ionization energy to a large ionization energy, and then order these for number three according to reactivity. So pause the video and then write those orders down, and then you continue the video and see how well you did. Okay, welcome back. So let's see how well you did. So radius, again, we have potassium, fluorine, and aluminum. And so we know that the radius is going to decrease, or it's going to increase from right to left, and it's going to increase from top to bottom. So the smallest radius is going to be fluorine, which is that top right corner, and then followed by aluminum, which is more to the right or more to the left, and it's a little bit lower in the table. And then you've got potassium, which is farther to the left and a little bit lower. So it's going in the direction of the diagonal. For ionization energy, barium has the smallest ionization energy. So remember, the general trend of increasing ionization energy is from the bottom right or bottom left corner up to the top right corner. So it's increasing from bottom left to top right. And so barium is closest to the bottom left. And so that would be the smallest ionization energy. Calcium is higher and more to the right. And then you have sulfur, which is more to the right and also higher. So barium, calcium, and sulfur follow that arrow, that general trend. So manganese and Re and Tc, those are metals. So there we want to look at the reactivity of metals. So they should follow that pattern. So again, if we're looking at manganese, Tc, and Re, we're looking in that group there. And so we said that as you go down our group, the reactivity increases. So that smallest is going to be the first one in the group, which is manganese, followed by Tc, and then Re. And then what about the nonmetals? So we have S, Se, and O, sulfur, selenium, and oxygen. So we said that the uh, trend for nonmetal reactivity is going to be the opposite of metals. So since metals, the reactivity increases going down the group, nonmetals, their reactivity is going to increase up the group. So the lowest is going to be Se, selenium, which is the lowest in the group, followed by sulfur, and then going up to oxygen. Oxygen has the greatest reactivity in that group. So here's a quick recap. So the vertical levels, so when you're going up and down a group, shielding is a factor due to energy levels, right? So more energy levels as you go down a group, you're adding an energy level. The valence electrons, the outermost electrons are getting farther from the nucleus. They're feeling a less of a pull. The shielding is decreasing uh, the amount of attractive force of the nucleus, and so that's something to keep in mind. Also, the horizontal, when you're going across a period, it's the effective nuclear charge due to the number of protons. So as you go from left to right, the number of protons is added to the nucleus, so you're increasing the number of protons, and so therefore you're increasing the effective nuclear charge, and therefore the attractive force of the nucleus is stronger, pulling in the electrons more tighter, more strongly. And so here you could see the general trends of radius, ionization energy, and electronegativity and reactivity.